All right, so now how do we set up search areas? We're going to talk about how to set up search areas and how to prioritize them. And that makes a lot of sense when you're looking at big, huge areas of water. One of the biggest mistakes people do is they go out in these big, large areas of water and they try and search it all at one time. One big, giant search area going back and forth and trying to cover it all at one time. And then they're fighting lifting the towfish and dropping the towfish because the curvature of the bottom is going up and going down. Then they're hitting objects because they didn't know the objects were there, and it can be very, very cumbersome. So how do we set up different search areas and how do we prioritize them for our search? All right, so we're going to start off looking at this map. And if we look at it, we can see our depth calculations. And our depth calculations here are going to assist us for our primary search patterns or search areas. We're going to break this area up into multiple search areas. And you can see on here, we have the contour lines, right? And then we have these large areas of open water. And how would we search this area? How do we break this apart into different areas of search so we're not fighting our towfish? Okay, because again, if you're to create a bearing, and my mouse keeps disappearing, but if you create a bearing straight across here, right, and this was our search area, okay, if we were to move across this area, we would have to lift our towfish over these points and then lower our towfish back down into this area, lifting it again, and then dropping it again, okay? A lot of the times, the water that you're running in is going to be a crazy dynamics, crazy seafloor dynamics, and you're going to get really tired or you're going to wear out your crew lifting and dropping that towfish. So we can break this area up by depth in different types of searches for different areas of this map. All right, so the first one we'll talk about is we would probably break this area off here. So we would create, let's see if I have a little annotation mark. All right. So we could break a search area off here. We would probably have another search area here. And another search area here. And probably another one encompassing out here. So you're going to break all of these areas up into individual search areas. Instead of trying to do this all at one time, that way we can kind of set our towfish and forget about it, and we can just monitor our screen so we can visualize. Instead of worrying about lifting and lowering that towfish, let's get it set to a specific height, and then we'll monitor and watch for anomalies coming down. So we're going to look at this upper left-hand image first, and that is our vessel moving across, beginning our first leg of our search. And as it's moving across, say we're looking for a body. So if we're looking for a body, the best range is right around 65 feet. So 65 feet on both sides, that's 130 foot of swath. And so the distance from one leg to the other needs to be covered by one side of your range. So again, if we are using that method where we need to cover both sides and we're at 65 feet of range, your next leg is going to be approximately 65 feet away to a point. So now we got to talk about nadir because we have to also cover our nadir from our last track. If you remember from our first video, we went extensively into nadir and what it is and why it's there. So I won't cover that completely, but what I want to cover here with you is the distance that you are missing below your boat. Again, as we talked about in the first video, we went over the myth that this entire black area is missing below your boat. That is actually a representation of the height of the towfish, not the area you're missing. And so how do we calculate the area that we're missing? Well, if we have our range, if we look at our little boat diagram down here, we have our range. If that is 100 feet of range looking out, that means our towfish is going to be 10 feet off the bottom. And we are looking at a 10-degree down angle. And so if we are 10 feet off the bottom of 100 foot of range, that means we will be missing 1 foot below the vessel on one side of our range. So swath, it'll be 2 feet. So at 65 feet of range, moving across, we are going to be at 6.5 feet above the seafloor, which means we will be missing 6.5 inches down here at the bottom. So 6.5 inches of our port range plus 6.5 inches of our starboard range means we'll be missing 1 foot. Well, how do we cover that when we are doing our search pattern? We need to make sure that we cover that, and we do that through what's called overlapping. And so you want about a 10% overlap of your last pass. And so we can kind of see that in our lower right-hand corner image. We can see that we are overlapping slightly our last pass. And so, of course, when we're moving and we turn around, our green is going to be over green, and we turn around and our red will be over red, and that is doubly visualizing each pass. But the overlapping that I'm talking about is when you're overlapping that nadir. So if your range is 65 feet, right, we're looking 65 feet off to this side. Our leg spacing should probably be 60 feet, okay, giving you a 5-foot overlap. Okay, and in that 5-foot overlap, and you can rough estimate about a 10% overlap. So if you want 65 feet, 6.5 feet would be that exact 10%, but roughly a 5-foot overlap on that would be fine. Just to cover the area we've missed in the nadir. And so then our next pass, our next leg of our journey would again be another 60 feet with a 65-foot range. We're going to move back and forth across. And as we're moving back and forth, you're going to have green over green and red over red. And of course, the green and red is your range. If you don't have a system that covers that, you're going to have to calculate it. Okay, most professional grade sonar systems should have some type of history behind it and show you to scale what area you've covered. If your side scan does not have that, you can build that into your chart. It'll take a little bit of time, but you kind of want to do that so you can see what area you've actually covered physically, okay? When you're out looking on the water, it's very, very difficult to look out and say, yeah, we already covered that area, right? No land around, boats moving back and forth with the wind and current. How else are you going to be able to tell whether or not you've covered an area? And so you want to make sure that the system you have will display that so you're not missing any areas. If you have a missed area, they call that a data holiday, where you went around an area and you're not actually seeing it and it's being missed. So again, parallel, back and forth, we call it mowing the lawn. Why do we call it mowing the lawn? Because when you actually mow your lawn, normally when you turn around, you cover, right? You move your lawnmower over the edge of the last pass that you covered, and you go back and forth down your lawn, right? You want to make sure that you mow where your tires rolled on the last pass, so you can cut that portion of your lawn as well. And so that's why it's called mowing the lawn. But you're going to go back and forth. And when you are done, you'll do another pre-search as you're leaving, going to your next search area. All right. Our next search we're going to be talking about is the track line search. And the track line search is what you're going to be doing around bridges, dams, piers, land, large buoys, things like that. But basically, you're going to be moving your vessel in line and parallel to any object that's in the water. Our search areas won't necessarily cover some of the area of water. And so that area of water, we can't really get our towfish into to create a parallel search pattern within here, right? And so since we can't create a parallel search pattern in there, we're going to have to do a track line search. And that's where we're just going to follow the contour of the land and come back out. And so that's what this blue line represents.